In this video, we're going to walk through several examples of writing equations of lines that are perpendicular to other lines. Well, all right. Well, what does it mean to be perpendicular? Well, the lines are going to intersect, and they're going to do so forming a right angle or a 90-degree angle. So what are the characteristics of the slopes of these kinds of lines? Well, the slopes of lines that are perpendicular have a product of -1. In other words, you could say their slopes are opposite reciprocals. Opposite means they have different signs. One's positive, one's negative. And reciprocals, of course, means you flip the fraction over. So the numerator becomes the denominator, and the denominator becomes the numerator. Okay, so let's go ahead and take a look at a few examples of some slopes here. So if we have a slope of 3/2, what will be the perpendicular slope of that? Well, it's the opposite reciprocal. So we're going to say a perpendicular slope will be, well, this is positive, so it'll have to be negative. And we're going to take the reciprocal, so 3/2 becomes 2/3. So we're going to say that the slope that's perpendicular to 3/2 is -2/3. All right, well, how about the slope of -5? Well, this is negative, so this one will have to be positive. And this is 5. You could also think of it as 5/1. So this will be positive 1/5. And now these two slopes are perpendicular to one another. Okay, well, let's look at m equals 1/4. So if they're going to be opposite reciprocals, this one's positive. So the perpendicular slope will have to be negative. And of course, if it's 1/4, when we take the reciprocal, it'll become 4/1, or we can just say 4. And finally here, if we have a slope that's -1, a perpendicular slope, well, we'll change the sign, so it'll go from negative to positive. And the reciprocal of 1 is just 1. So if you have a slope that's -1 and a slope that's 1 on a couple of lines, we know that those lines are perpendicular to one another. Okay, so let's go ahead and do some examples real quick. So we're going to look at 5 different lines, and these lines are all going to be in different forms. So we're going to have slope-intercept, point-slope, standard form, and of course we'll throw in some horizontal and vertical lines as well. So for our first example, we're going to start with the line y equals -2x plus 3. And our new line is going to be perpendicular to this line, but it's going to pass through point P, which is 4, -3. Well, all right, how do we go about doing that? Well, this line is in slope-intercept form, and it looks like its slope is this -2 right there. So what would the slope be of a line that's perpendicular? Well, again, opposite reciprocal. So we're going to change this sign from negative to positive, and the reciprocal of 2 is 1/2. So we're going to say the perpendicular slope is positive 1/2. And if we know it passes through this point 4, -3, then we can write the equation of this line a couple of ways. We can do it in point-slope form, which is where we're going to start. So y minus the y-coordinate equals m times the quantity x minus the x-coordinate. And then later we'll do it in slope-intercept form as well. Okay, well, y minus the y-coordinate. Well, the y-coordinate is this -3 because we have an x and a y for every ordered pair. So y minus a -3 equals my slope. And of course, my perpendicular slope we said was positive 1/2. And that'll be x minus my x-coordinate, which is 4. So let's go ahead. We have a y minus a negative. So we're going to go swoosh, swoosh. And we're going to say y plus 3 equals 1/2 times the quantity x minus 4. So this is the equation of a line perpendicular to this original line, but passing through this point P 4, -3. So this is the line written in point-slope form. Let's go ahead also and write it in slope-intercept. So we have y equals mx plus b. And of course, we need to first solve for this y-intercept because we're not sure what that is. But we do have some values for y, m, and x. So y is just this y-coordinate. And m is our slope, so 1/2. X is this x-coordinate, so 4, or 4/1. And we're going to solve for this b. Looks like we can cancel some things here. So it looks like -3 equals 2 plus b. So when I subtract 2 from both sides, it looks like b ends up being a negative 5. So I could say in slope-intercept form we have y equals 1/2 x minus 5. And again, this is the same line, but it's the equation of the same line as this guy, but he's in slope-intercept form instead of point-slope form. Well, how could we go to kind of check our answers, go from point-slope to slope-intercept? Well, let's just go ahead and distribute this 1/2 and then subtract 3 from both sides. So we'll end up with y equals 1/2 x, and then half of negative 4 is negative 2, and the negative 2 minus 3 is negative 5. So you see that they are both indeed the same. So what we've done, we started with a line, this y equals negative 2x plus 3, and we wanted to write the equation of a line perpendicular to this line, but this new line that's perpendicular needed to pass through this point P for negative 3. So we went ahead and wrote the equation two different ways. So we did it in point-slope form and slope-intercept form, and then we took our point-slope and put it into slope-intercept and just kind of checked to make sure it was right. So for these 5 examples, I'm going to give you a graph as well. So here's the graph of this first example. In this second example, we want to write the equation of a line that's going to be perpendicular to this equation given to us in point-slope form, but our new equation is going to pass through Q, which is negative 10, negative 7. All right, well, what's the slope of this original line? It looks like our slope is 5/3. So I would like to find a perpendicular slope to 5/3. So 5/3 is positive, so my perpendicular slope will be negative. And this is 5/3, so my perpendicular slope will be 3/5. So I've gone ahead and I changed the sign and I flipped it over, so negative 3/5. So this will be the slope that we're using now because it's perpendicular. So let's go ahead and start by writing the equation in point-slope form. So y minus the y value equals the slope times x minus the x value. All right? Well, our x and our y we can grab from our ordered pair here, negative 10 and negative 7. So y minus the y coordinate is negative 7 equals our slope, which we'll use our negative 3/5, and then x minus our x coordinate, which is negative 10. All right, well, I have in a couple of cases minus and negative, so swoosh, swoosh, and swoosh, swoosh will give us an addition right there. So y plus 7 equals negative 3/5 times the quantity x plus 10. All right, so that's the equation of the line in point-slope form. Let's go ahead also and do it in slope-intercept, and I do it in both ways just because, I'm not sure which way you're comfortable doing, so we'll just kind of do it both, and you can follow along on whichever one you like. So y equals mx plus b, so of course we need to solve for that y-intercept. So our y value was our negative 7. Our m was our perpendicular slope of negative 3/5. Our x was negative 10 or negative 10/1, and plus b. And again, that b is what we're solving for. Looks like the 5 and the 10 I can cancel to make a 1 and a 2. And a negative 3 and a negative 2 can cancel. So I have negative 7 equals 3 times 2 is 6 plus b. So when I subtract 6 from both sides, it looks like my b value is negative 13. So my equation then in slope-intercept form will be y equals negative 3/5 x minus 13. Okay, so here are my two equations. They are describing the same exact line. So let's go ahead and transition this one from point-slope form to slope-intercept by distributing and then subtracting 7 from both sides. So y equals negative 3/5 x, and 3/5 of 10 is 6, but it's negative, so negative 6 minus 7 is negative 13. And you'll see, indeed, they are the same equations. So what did we do just now? We wrote two equations, one in point-slope form and one in slope-intercept form. And we wrote these equations to lines that are perpendicular to this original line but passing through point Q. And here's the graph of what that will look like. In this third equation, we're going to write the equation of a line that's perpendicular to x minus y equals 2, and this is written in standard form. But our new line is going to pass through point K, which is negative 2, 9. Well, this being in standard form, I don't know what the slope is right off, so I'm going to have to put it in some other form so I can get the slope. So if we start with x minus y equals 2, I can subtract x from both sides, and I'll have negative y equals negative x plus 2. And then I can divide every term by negative 1 to get this y by itself. So it looks like y equals x minus 2. Well, okay, so I put it in slope-intercept form so I could grab the slope. Well, y equals x minus 2, what is the slope of this right here? Well, that slope is just this number in front of the x, right? Well, what is that number? It's going to be 1. So my slope equals 1. So if I'm working on writing a perpendicular line, I need to find the slope that's perpendicular to 1. So I change the sign from positive to negative. And what's the reciprocal of 1? Well, 1. So if we have a slope of 1, the perpendicular slope will be negative 1, because opposite reciprocals. Also, their product makes negative 1. 1 times negative 1 is negative 1. Well, okay. Well, I have this point K, which I have an x value and a y value. And I also know my perpendicular slope is negative 1. So let's go ahead and write the equation first in point slope form. So y minus the y value equals the slope times the quantity x minus the x value. Well, it's y minus my y value of 9 equals my slope of negative 1, and then x minus my x value of negative 2. So I have minus and negative, so swoosh, swoosh. So I'm going to say y minus 9 equals negative. You put negative or 1 or just the negative, and then x plus 2. So this critter is written in point slope form, and that's the equation of a line perpendicular to this line, but passing through point K. And let's go ahead once again do the same thing, but in slope-intercept form. So y equals mx plus b. So my y value was 9, my m was negative 1, and my x is negative 2 plus b. So 9 equals 2 plus b. When I subtract 2 from both sides, it looks like my value of b is going to be 7. So my equation should be y equals negative x plus 7. And again, these two lines are describing the same thing. So we have two equations, same line. So let's go ahead and transition from point slope form to slope intercept and just kind of verify that they're the same. So I will distribute the negative, and then it looks like I'll add 9 to both sides. So y equals negative x. It'll be a minus 2 plus 9 will be a positive 7. And yeah, that's the same thing. So what we've done here, we've written the equation. In fact, we've written two equations. They're describing the same line. And this line is perpendicular to x minus y equals 2, but it passes through point K, negative 2, 9. And here's the graph of what that looks like. In these last two examples, we're going to focus on horizontal and vertical lines. And the relationship between any vertical and horizontal line is that they are already perpendicular to one another. So when graphed, they will intersect, forming a right angle. Okay, so in this fourth example, we're going to write the equation of a line perpendicular to y equals negative 2, and it's going to pass through point L, which is 5, 2. Well, y equals negative 2 describes a horizontal line. So if we have a line that's going to be perpendicular to a horizontal line, it's going to be a vertical line. And all vertical lines are x equals the x-intercept, or the x value, and that's given by the letter A. So in our case, we have 5, which is the x value, so the equation is going to be x equals 5. So we needed something perpendicular to this horizontal line y equals negative 2, and that would be the vertical line x equals 5 passing through point L. And here's what the graph of that looks like. In this final example, we're going to write the equation of a line that's perpendicular to x equals 3, but this new line is going to pass through point L, 5, 2. Well, x equals 3 describes a vertical line, and we've already said that perpendicular to a vertical line is a horizontal line. And all horizontal lines have the equation y equals b, which is the y-intercept, or, y equals the y value. So we have a y-coordinate here, which is our y value, in our point, and that's 2. So the equation of the line that's perpendicular to this vertical line will be a horizontal line, y equals 2. And y equals 2 passes through point L and is perpendicular to x equals 3. And here's a look at that final graph.